Hey, hi everyone. Good evening, all. I believe my voice is audible to everyone, right? Okay. Firstly, I'm really sorry, friends. I really apologize for being 10, 15 minutes late. It's due to this application, so it makes me delay. So I really apologize for that. Thank you so much for joining the session, friends. Thank you so much for the joining the session today, which is Python visualization packages. So, as part of today's webinar, I'm going to take Python, visualization packages. So, before that, welcome to 360 Digit MG, friends. And firstly, I want to introduce that 360 Digit MG is basically a training institute, and we provide all trending courses which is trending in the market, friends. So here the first picture you can see here, we recently launched a domain analytics program which really helps for different industries and different profiles. So here if you just look at that, we actually start life science and healthcare for life science people, financial analytics for finance departments, and marketing analytics for marketing people, HR analytics, supply chain analytics, cyber security, data science, internal auditors, and so on. So all these are our domain analytics, which very new to our program. So this is our first thing, and then so welcome back to 360, and this is me. My name is Nikhil Miriara, friends. I'm working as a data scientist in InnoDataTix. I have around 4.5 years of experience as a data scientist. Okay, I have coming to project. I almost have 25 plus project and product experience, friends, and along with POCs. When I say POC, it's a proof of concepts. So I have experience on various domains such as healthcare and healthcare departments and financial departments, airline industries. I also work with some of the famous companies like Coca-Cola and uh, Paradise, which is from Indian-based company, and Korean Airlines, Crujet. All these are some of my clients, and I work for on this machine learning and artificial intelligence project, friends. So this is my quick introduction. And coming to our institute, we have value added accreditations, friends. Basically, our trainings are certified by City and Guilds from UK, which is 150 years old university, and UTM certification we have, that is University Technology Malaysia. We have accreditation from that university, which is top 5 universities in Malaysia and top 100 universities in worldwide. And we also have TUE SUD certification, which is one of our accreditation as part of this 360 friends. So this is what I just want to quickly brief you about our institute. So as part of today's demo or today's webinar is based on Python data visualization packages, friends. Okay, so this is our basic today's agenda. So before I start my Python programming on top of this data visualizations, I want to discuss some thoughts on what do you mean by visualization and how it is really helps us. Right? I just want to brief you guys how these visualizations are really helps us in the current world or as part of our daily requirements. So what do you mean by a visualization? Coming to the visualization, when I say visualization, it's basically a graph. So how that graphs, and one second, just give me a second, please. Just give me a second. I just open a tool for my writing pen. So let me go back. Yeah. So coming to visualizations, so how these visualizations are really helps us. What is the need of it? When you ask me such questions, see, if I show you a data set, I mean, in current world, the data is a big resource for us, right? By having the data, we can do a lot of analytics and we can come up with a good optimization result, friends, right? So when we have a data, when we have huge amount of data, since we are all digitalized and we have a lot of industrial sensors and we are able to extract the data, even you guys are extracting a lot of data every day by just logging into your Facebook or logging into your phone. You have your Fitbit watches or body tracking watches or sensors or whatever you name it, all generates the data, right? Now once again, so how these data visualizations are going to help us? If you guys just look at the data, it will be in rows and columns. Probably let's take a structured data. When I say structured data, that means I have proper columns and proper number of rows. Columns means this and rows are this, right? I have a structured format of columns and rows. If I have such kind of columns and rows, that's called structured data. If I have this structured data, let's take one Excel file or CSV file where I have 1,000 number of records. 1,000 number of records. For example, this 1,000 number of records, I have, let's say I have a variable called age. There is a variable called age column. And there are certain people who are there in my data, like 1,000 number of people were there. Out of this 1,000 people, I want to identify what is the least number or least age, and what is the highest age, right? What is the highest age and what is the least age? If I just look at the data, can I able to understand? If I just go back, for example, if I just go back and if I just open an Excel file, any of this Excel file, let's say this file, this is a COED data set, friends, Indian based COED data set. So for example, if you just look at this data set, if I ask you coming to this particular, let's say altitude, can you guys please tell me what is the least altitude? If I just scroll you like this, can you guys able to identify what is the least value? Or what is the highest value can able to identify? No. You can't do that because by just looking at the data, we can't remember or recognize in our brain. So our brain is actually able to identify or remember or recognize the shapes easily than a information. When I say information, this is an information. The numbers were information, the names were information, right? So all these were information, but our brain is very much molded and it can able to remember the things for so long time, which is based on a visualization. When you have a graph, when you have some shape, you can able to remember for so long time, right? Simply, if I just say, I'll draw a triangle like this and I'll say that, guys, please remember this particular triangle and circle. Triangle and circle. Just remember this particular diagram for next 1 year. You guys can able to remember this particular graph for next 1 year. You can. But if I write some number, if I just write some number, If I write some number like this, if I ask you guys to remember this number for next 1 year, you can't remember that, because your brain will be easily stores the shapes than information, right? So this is how the data is very much important. The visualizations are very much important today, because we have huge amount of data. We can't understand the data just looking at the numbers or the data. We just need to draw a visualization. Rather than this, I'll draw a visualization here. I'll say that the least number is starting from here, the highest number is going like this. Then it will be easy for me to identify which is my least number and which is my top number. So that's how visualization makes more sense for an analyst or data scientist or even a layman. Whatever the day, for example, just take a bakery shop, a grocery shop. Even that guy need to understand how is their sales. He can't understand just looking at the data. He need to have some kind of a visualization saying, hey, my sales are going up or down or up or down or up or down. Makes sense, right, guys? So visualizations are very important for everyone. So this is why, this is the reason that we are going to learn this data visualizations. And being a data scientist or being an analyst or being a general person, even you, if you have the data, then you supposed to learn the data visualizations for sure, which makes more sense, right? So that's what my explanation why you guys need to learn this data visualizations, right? Then let me just jump into next question. I have a few slides, friends. I have few slides here. I'll just walk you through the slides and I'll just go back to my Python code and I'll explain the Python code, okay? So here, coming to data visualization. What is data visualization? You came to know, like it's graphs basically, right? All graphs. You say histogram. This is called histogram, friends. You say histogram. You say bar chart, right? You say pie chart, right? You say a different kind of charts, friends. Maybe scatter plot, line chart, area chart. All these were different types of visualizations. And coming to why data visualizations, we just came to know that, what is the reason behind this? Because we can able to understand, we can able to recognize, and we can able to remember for so long time. So that's why data visualizations are very powerful things, and it makes our lives easy, right? And you know what? Doctors, or there is a theory that things can be remembered so long time. I mean, shapes, for example, when our human brain is designed in such a way that if you're just looking at anything, you are not directly looking into the middle part or the entire part of that particular thing, friends. First, you will look at the corners, like, you'll figure out the corners. You can observe anytime. I mean, it all happens within a fraction of seconds, or let's say milliseconds, or very fraction of seconds. It is able to recognize your corners. Based on that corners, you are finally recognize, okay, this is so and so thing. For example, there is a spoon. You'll just figure out first corners. Your eyes will figure out the corners, and then it will identify the shape. And then it will identify what kind of a thing it is. Either you name it a spoon, or it's a table, or it's a car. Whatever you name it, it will identify the corners first, and it will go back to the major picture, right? So this is how the things works with our humans, and that's why data visualizations are very, I mean, you can able to remember the things easily. I don't want to repeat the things. Okay. So principles of the visualization. What do you mean by principles of the visualization, Nikhil? If you guys ask me such questions, I'll say you See, principles is nothing but you need to follow certain rules, friends. I'll ask you one simple question. For example, what do you mean by rule? Do we really have rules in Python or visualizations? Yes, absolutely. You guys have some kind of a rules in data visualizations. Okay, what is that rule, Nikhil? If you ask me something like that. So when I say rules, I'll ask you a simple question here. What is the difference between histogram and bar chart? What is the major difference? Like both are look same, but what is the major difference? This is histogram. This is bar chart. So what is the major difference? You know what? When you are supposed to draw a histogram and when you are supposed to draw a bar chart. For example, here I'll say that you need to or you're supposed to draw a histogram when you have a continuous data. If you ask me, Nikhil, what do you mean by a continuous data? I'll just ask you to go back to the data, types of data. But for a glance, I'll just tell you, continuous data is something which, which can be measured in a scale, on a scale. For example, let's take temperature. Let's take temperature. When you call temperature, the temperature is actually starting from 0 degrees to 100 degrees, for example. This is continuous. You can actually measure it on a scale. Like you have 10.5, right? So when you have such kind of a temperature or height or weight or whatever you name it, all these comes under continuous data that you are trying to plot it. That is called histogram. Now what do you mean by bar chart? Bar chart is for discrete data or categorical data. Let's say you have different kind of ice creams. Let's say mango or orange or chocolate. You have different kind of ice creams. So I'll draw a different bars. There is no connectivity between one to other. Here you have a connectivity because it is continuous. It is continuous. It is same. But here it is not like that. Chocolate and mango and orange are totally different. So there is a distinguish between one bar to other bar. So when you need to use your continuous data for your histogram and discrete data for bar charts. So these are some of the visualization tools. Means your data should not give you an error value, or your visualization should not make you lie. Your data should not lie you, or your visualization should not lie you, right? So this is what as part of data visualization principles. And our final goals of this particular data visualization principles will be, I need to get a good visualization with more information, and it should easily understandable, right? You guys need to easily understand it, and you guys need to easily, it should give more information, right? And it should not lie. It should not lie. It should not give a wrong value to you, right? In one single plot, you should able to do a lot of information should come up. So all these are some of the goals, or some of the expectations we have as part of our data visualizations. So this is what I just want to give a glance on why we need these visualizations today. And now I'll just walk you through the Python code, friends, and I'll make you guys to understand how that Python code works and how we can draw a different kind of visualizations using Python. So here I'm going to use Anaconda Spider as my IDE, friends. When I say IDE, it is called Integrated Development Environment. Okay, Integrated Development Environment. So I'm going to use Spider IDE here. Now, as part of my visualizations, coming to Python, what I supposed to do? So I supposed to download certain packages to draw the visualizations, friends. What is that packages? So I have matplotlib package, one of the visualization package in Python. Sieben package, one of the visualization package in Python. ggplot is one of the visualization, right? Alter is one of the visualization. So all these are basically different packages we have. So today I'll pick up some of the packages and I'll explain you about how it works. And we'll also discuss about some of the visualizations for sure. Yeah. Now, let's just go back. Okay, fine. So I just came back to my code, friends. This is my spider. This window will help me to draw, write the code. This window will help me to store the values where I'm just pointing now, right? And this window will help me to draw the visualizations or get the visualizations done or the result. Now, what I'm going to do is I'm going to execute this pandas package. Pandas will help us. Pandas will help us to get the data, friends. Pandas package will help me to get the data. Okay. And now what I'm going to do, I'm going to take one of the function in this pandas package that is called read_csv. I'm going to read a CSV file here. From that, I'm going to draw the visualizations. Right? Just give me a sec. Okay. So I'm just going to execute this. I'm going to get the data from my local machine, friends. I have a CSV file called MBA dataset. It is basically a graduation program data set. I have different universities in that particular data set, and there's certain variables, certain dimensions I have regarding about that particular university's data set. I'm going to execute this particular line, and I get the data set of MBA. So pd.read_csv will help me to read the CSV file, and I just got the MBA data set. So if I just open this MBA data set, this is basically my MBA data set where I have data serial number, work experience, and GMAT scores. So it's an MBA program data set where I have work experience and GMAT scores. Now, if you see the type of this data set, what kind of a type it is? It's basically a pandas data frame. Remember one thing, friends. I just imported CSV file, means it's a CST extension. You might have Excel extension, or you might have different kind of file formats. When you guys are actually importing the data into Python, it will turn up into data frames. When you try to import the data using this pandas really helps us to import the data into a Python. When you're importing the data, it is no more, it is a file, it will carry out that file format, friends. It will turn up that particular file into data frame. So here you have the data frames. So I'll just execute it. The moment I just execute it, the data will be turned up into data frame. Okay. So that's why when I say type is means what kind of a data type it is. It's an MBA data. Now, take the matplotlib package. Matplotlib. Coming to matplotlib package, I just take matplotlib.pyplot as PLT. Okay. Now, plt.hist. So this matplotlib is also one of the package name, friends. So I'm going to use this package for my visualization purpose. So here what I'm going to do is I'm going to take this matplotlib package as just saving it as PLT. This is you can take it as an alias name or nickname. Take this plt.hist. Basically in PLT, in this matplotlib package, you have various functional difference. plt.tab, when I just say plt.tab, all these basically are matplotlib package functions. Right? All these are different functions in my matplotlib package. It means I can draw with different visualizations. So here I'm trying to take one of the visualization called histogram. I want to draw a histogram for my GMAT scores. So this is a histogram. You guys can able to see that. Right? Histogram, which is for my continuous data. I'm trying to draw the histogram. So since my score is continuous, I'm trying to draw the continuous data. That is called histogram. Now, Nikhil, can I draw a box plot? I really don't know you guys are aware of this box plot or not, but box plot is also one of the major visualization which can be used by an analyst or a data scientist or whoever it is. He can able to identify a lot of insights using this box plot. To draw this box plot, plt.boxplot is a function. So I'm taking my GMAT scores as my box plot, and I take the y-axis label as GMAT scores, and I'll just run this particular line. Can you guys see this box plot? This is called box plot. So where this box plot really helps us to give the information about what is your minimum value, what is your maximum value in that particular GMAT scores, and where your maximum data is available. You have maximum data between 725 to 680. From 680 to 725, you have maximum data points. So this box will explain you 50% of data points where it is located. And this is the upper whiskers, this is a lower whiskers, and this is called outliers. Outliers means out of the range. For example, there are 10 people in the classroom, and for example, imagine that all these people are ranging from 20 years to 30 years. But there is another person who is 80 years old. That 80 years guy is 80 years guy is basically an outlier. Right? So outlier, you can able to identify the outliers using this box plot, and you can able to identify the range between this in the given data and where the maximum points are located. Similarly, you can actually twist that data, that particular file. You can make it like this, just changing the direction, saying 1 and 0. Same function. If you want to know more about it, okay, Nikhil, how can you able to control it? I just help you with help function. Help function will really help us to identify what are the parameters are available in that particular function. So all these are different parameters which is available in that particular function. You guys can easily read out that particular function name. You will also have that parameters description which is given here, and you can make use of it and make your job done. Right? So you need to take help option. If you guys are not able to see, I'll just zoom it up. Yeah. Next, I'll just take this NumPy package as NP. NumPy package will help me to take some statistical steps, friends. So I'll tell you how this NumPy package is going to help me. Here I'm going to draw a bar chart now. Histogram is done and box plot is done. Now I'm going to draw a bar chart. So PLT is the matplotlib package.plt. Plt.bar is basically a function where I'm taking height equal to GMAT score, and x-axis is I'm arranging 773 records. Because I have 773 records, I'm just arranging the numbers and I'm just drawing the bar chart for this particular data. You'll see a messy bar chart here, friends, because a bar chart should be with a very less categories, but I'm taking 773 categories. That's make me a clumsy bar chart. where you can't really observe anything, but okay. This is a function name to draw that particular bar chart. Since I don't have any categories here, this is my challenge, friends. Right? No worries. Let's see. Let's go and understand another things. For that reason, I just coming up with some kind of data visualization, another data set which is called as empty cars. Empty cars is one of the data set which helps us to get the another data set. So if you see that data set, empty cars is basically a cars details, friends, where you have all the cars here and their information. Now, using this, I mean, when you just look at this cars data, I have mileage, cylinders, displacement, HP, weight, like gears or carb or AM. This is all information regarding about cars. You can actually see some of the cars here. Probably your favorite car might be there. See, you have any of your favorite car? Mercedes, Ford, or something. Okay. So this is a data set about. Now I'll pick up this data set and I'll try to draw some kind of visualizations and understand how it works. Empty cars dot mileage. I'm trying to pick up the mileage column. Mileage is nothing but mileage of that particular data set, that particular car. So this is a mileage, how much mileage it is actually giving me. Now I'll pick up that mileage and I'll group by with empty cars dot gears. Okay. So I'll take this particular data set and I'll group by with gears. Gears is another column which I'll just group by it, and I'll plot a line plot. Just look at this line plot. Okay, just see this line plot. What I'm trying to do is I'm trying to take mileage as my y-axis, or see this, my y-axis is my mileage, and I'm trying to group by my gears. There are 3 types of gears which is there in my data set. That is 4-gear engine, 3-gear engine, and 5-gear engine. 3, 4, 5. 3, 4, 5 gears engines I have it. So here I have different gears which is plotted here. 3 different lines are 3 different colors or 3 different engines. Now I'll take this pie chart and I'll draw the pie chart now. So empty cars dot gears, I'll take the number of gears, different number of gears, and I'll count it. Value underscore count will help me to count number of gears. So how many 5-gear engine were there? How many 4-gear engine were there? And how many 3-gear engine? I'll just count it. And I'll draw a pie chart. So 3-gear engine is this much, and 4-gear engine is this much, and 5-gear. So when you just look at this data here, you can't able to identify easily which is the highest count. But when you just look at this image, you can easily able to understand your 5-gear engine is having less count, and your 3-gear engine is basically having more count, and 4-gear engine is having the second position in the given gears. So I'll just say kind equal to pi. Area chart. Okay, what do you really mean by area chart? It is almost equal to your line chart. So I'm just taking up this mileage from this empty cars data set and plotting up a area chart, kind equal to area. So my area chart will help me to draw the area under this line. Got it? So it's nothing but the line chart and area chart is completely same, but the color, it will be colored under the area, under the line, and there it will not colored up. Next, I'm taking again bar chart by taking this particular gears and cylinders, number of cylinders. I'm just picking up the bar chart. So previously you didn't saw a proper bar chart. Now you can able to see the proper bar chart with the different dimensions. I just pick up the gears and cylinders, and I plot it like a bar by using this PD dot cross table. So here I just use PD pandas function using pandas also I can able to do this particular job. Okay. Now, using my Sieben package, I can able to identify, even Sieben, SN. So here, import Sieben as SNS. So I'm just importing the Sieben package as SNS. And now SNS.boxplot will help me to draw a box plot. I mean, even you can use this SNS package and you can able to draw the box plot, friends. And I take x-axis is my gas and y-axis is my mileage, and I'll take the data set. So this is what the box plot I colored up with the different colors, right? Because it is a 3 different categories like 3-gear engine, 4-gear engine, and 5-gear engine, and y-axis which indicates the mileage for that specific engine, the gas, the specific gate, right? You know what? I can also use this SNS package. There is a function called pair plot. What this pair plot will give you is it will give you the entire detailed information of entire data set. See? It is actually giving me the histogram information of each column to itself, and it is giving me the relationship between 2 different columns. For example, just say work experience and my GMAT scores. This is my scatter plot. You guys can see scatter plots and my histograms all together in one single screen of entire data set is basically a pair plot. Is that pair plot? Pair plot function. So pair plot is also one of the important function where you can within one screen you can able to identify the relationship, the scatter plot between all your variables along with your distribution of the each column. So how the data is distributed, how this GMAT data is distributed, you can able to see that. Now, so I can able to draw the scatter plot here, friends, by just taking the plt.plot will help me to draw the scatter plot. Where scatter plot? Okay, sorry. Here it is actually saying line plot. My bad. Okay. So here I'm just trying to plot everything and I'm just trying to draw a line, friends. Okay, I'm trying to draw a line for my given 32 number of records, and I'm trying to say what is my mileage. First record, how much is the mileage? Second record, how much is the mileage? Third record, how much is? Fourth record, what is the mileage? Fifth record is, right? So I'm just twisting off the directions. That's it. Y-axis into X, X-axis into Y, and I just join it by just red color. Circles and hyphen will help me. For example, if I remove this hyphen, it will help me just only with dots. I can also turn up into blue color by just saying blue. See, I want to just draw it now by hyphen. So it will connect each and every point. That's the only idea. See, here we have scatter plot, friends. For example, you just take scatter plot, plt.plot will help me with the scatter plot. And I just draw this one. So this is the scatter plot which helps me to identify the relationship between my mileage and HP correlation. So scatter plot will give you the direction and the strength of the data. So it is basically a negative direction. It have a negative direction. As and when your HP increases, your mileage decreases. That's what it is trying to tell you. As and when your HP is increasing, the mileage is decreasing. As and when your HP is decreasing, your mileage is increasing. That's what the information you can able to identify. That's a scatter plot relationship. As there is a relationship between these two things, right? And here, if you just look at this one, I already draw the pie plot again. I'm just repeating the things. Yep. Bar chart here. I'm just counting the values of gates. And same information I'm trying to draw a bar chart here. Instead of pi, I just kept bar. The entire information is same. Again, here I'm just grouping by with gates and MPG. I'm just drawing an histogram, kind equal to histogram. See. Now, here I have some information about scatter plot using SNS package. So using SNS package, which is nothing but Sieben package, I have cat plot where my x-axis is gates and my y-axis is MPG, and I take the data set from empty cars. See, it is showing me the number of gates: 3-gear engine, 4-gear engine, and 5-gear engine. 3-gear engine, 4-gear engine, and 5-gear engine, and where I'm able to see that particular MPG, mileage per gallon, along with my gears. So this is a scatter plot. Now, violin plot is something which, if you just same information I'm trying to take, and I'll say kind equal to violin. See this? The same distribution I'm trying to explain you. Next, I just changed my Boxen plot. See this Boxen plot, how it looks? A kind equal to Boxen, the same information I'm trying to keep, cat plot. And I just draw. See, Boxen plot will help me like this. These are the different visualization you guys can use whenever you want this, but I am trying to explain you the boundaries of the visualization, friends. Now here what I'm going to do, I'm trying to understand the distribution of the data, friends. So I'll take matplotlib, SciPy package. From SciPy package, I'll take stats and I'll take numpy. And using this numpy package, np package, I'll take this random.normal function, and I'll take some of the number of records, and I'm generating the records by this particular value. And if you can able to see the x value as well, there are 100 records were generated, right? You can able to see this. Now I want to just draw a distribution plot, DIST, distribution. If you want to draw the distribution, how the data is distributed, you just say distribution plot, DIST, which will help you to draw the distribution of the data along with the, that curve, the bell-shaped curve. Multi-plot grids. How this multi-plot grids is helping me? There is an iris data set, friends. It is basically it is a species data set where I have certain dimensions of an species of sepal length, sepal width, petal width, and I have species. I have different types of species here. That is setosa, versicolor, and virginica. There are 3 different categories of species I have. So I'm trying to take multi-plot. I'm trying to take multiple things in a single plot. So for that, I have an sns.faceGrid function. I'll take this iris dataset. I'll take this species one side, and I'll map this particular species of the distribution along with the sepal length. And just try to draw this entire situation altogether. See this? What I'm trying to do, I'm trying to keep sepal length as my x direction and my y direction with setosa, versicolor, and virginica. For all 3 different categories, how my length, sepal length is actually distributed, I'm trying to see it. My multiple things were arranged in one single graph, that is called multi-plot grid. Color variation. So your SNS package have how many color variations? I'm just trying to showcase you this, friends. You can keep on experimenting a lot of functions inside it. It is not the stopping point. I mean, this is not the final point. I'm just give a push up for all your functionalities, how many graphs you can draw and how it is going to help you, friends. I want you guys to just recap it by trying it and do a deep dive in it, so you will come up with a lot of functionalities. So sns.color platter will help me to identify how many colors we'll have in this. So I have these many colors which is embedded in this particular SNS. So I just want to show this number of colors, but these all functionalities will help you to just draw the visualization and get the insights, friends. It's not the final point. You have a lot of graphs, you have bivariate, you have univariate, you have multivariate. It's nothing but you can take one single dimension, you can take two different dimensions you can draw, you can take three different dimensions you can draw, you can have a lot of dimensions you can draw, but sorry, due to some time constraint or with the challenge of time, we can't able to continue all these things. But I request everyone to do a bit more research and bit more practice on top of it and get the things done. If you guys need this particular code, you just reach out to our salespeople. You can reach out to our website, or you can reach out to our salespeople from 360 Digit MG. And you can, if you request it, I will definitely provide this particular data sets for you, friends, and this code as well. And along with this, we are also going to publish this video in YouTube. You can also subscribe there, and you can get every video. We are going to post almost a week, 2 to 3 videos every week, and you can able to identify. You can figure out these videos there. So thank you so much for joining the session today, friends. I'll end up here. Thank you so much for joining the session. I believe that you guys got some of the important points as part of the visualization and how you guys need to drive it. We'll connect back soon with a new topic. Till then, take care, please. Bye.